Hello, welcome all. My name is Krunal Bauskar and I have been driving this MySQL on ARM initiative. As part of this initiative, today we are going to talk about MariaDB on ARM. I'm sure you would find a lot more interesting thing about MariaDB on ARM, and it will help you make a choice whether you should run MariaDB on ARM. So let's get started now. That's quick intro about me. I have been working in MySQL space for quite some time now. I have also worked with Percona as a PXE product lead, managing all aspects of the PXE, including performance. Before that, I worked with MySQL Oracle team as InnoDB developer and worked on some of the features during 5.7 timeframe. Also in past, I've worked on big data problems at Yahoo Labs, or I've also worked on a project for a startup, which is now part of Teradata. And we made the world fastest storage engine for MySQL and lot more such projects. Currently, I'm working at Huawei as part of open source DB group and responsible for all flavors of MySQL ecosystem, which include MySQL, MariaDB, and Percona. So as I said, I've been driving the MySQL on ARM initiative. So with that quick intro, let's now get started with our talk. So that's our agenda for today. So first we will see ARM ecosystem. We will try to understand why ARM ecosystem is gaining traction and why it is important. Then we will talk about MariaDB and ARM. And then we will see how MariaDB performs on ARM with some performance number. Towards end, we will talk about the state of ecosystem. So with that agenda set, let's get started. So first thing is ARM ecosystem. So I'm sure you have heard of ARM processors, but the context in which you have heard, probably most of us have heard, is mobile or network equipment. Most of our mobiles are powered by ARM processors because ARM processors consume less power, and so they can use the battery better. Now, if you stretch your thinking further, you would observe that ARM processors are also widely used in housing appliances. A lot of housing appliances use ARM processors. If you stretch it further, you would discover that ARM processors are also used in automobiles, especially self-driving cars, and with increasing automobile using electronic circuitries, defense space where the usage or usage of power is important. All these kind of application ARM processors have been gaining traction. Something which is new is HPC. HPC stands for high performance computing. Most of our products like application server, databases, big data falls under HPC. So thanks to the performance per watt, as I said, ARM processors are better at are optimal at consuming power, thereby reducing the cost of ownership. And they are getting more and more powerful with additional computing power that makes them a suitable choice for even use in HPC. Now, something which has changed in past couple of years is few years back, if you wanted to boot a very strong ARM instance for running your HPC application, there was nothing available. But in past couple of years, a lot of cloud providers have started offering ARM instances. For example, Huawei Cloud offer a ARM instance using its high silicon Kunpeng 920 processor. AWS offer ARM instance using Amazon Graviton 2. There's another startup called Ampere, which is trying to develop ARM-based cloud-ready ARM-based processors under Ultra series. So with options available, developer can now easily port their application to ARM, and user can eventually start directly running their application on cloud using ARM instance. But only having hardware doesn't help. So the software also has to be evolved, and that's exactly what we call as ecosystem. Fortunately, in past few years, all major OS providers has been able to provide OS support or OS releases for ARM. Then beyond that, if you look at projects, right, the applications, so most of the applications now are either supported on ARM or work in progress. For example, big data, the Hadoop, which was the base for big data application, is already now supported officially on ARM. Application servers, load balancers, databases are most of them are either work in progress or supported on ARM. So ARM Cloud Instance, so the reason why ARM is gaining so much of traction is in ARM is supposed to generate a direct saving of 30% by keeping performance on par. So that has been the motivation or USP why ARM is gaining so much popularity. So strong presence of ARM on data generating device is also going to fuel why ARM should be also used for backend server. So your complete end-to-end ecosystem chain is could be booted on ARM. Now it is estimated that by 2030, most of the HPC application will be running on ARM instances. Let's see, it could be earlier based on how the things evolve. Okay, so that with that, a short intro about ARM ecosystem. Now let's talk about MariaDB and ARM. So fortunately, MariaDB is already part of ARM. MariaDB has been releasing packages for ARM on distros like CentOS and Ubuntu, while there is a work in progress going on to add support for more distros in near future. So we are hoping that almost all the distros, major distros, will be supported. MariaDB not only support MariaDB server on ARM, they have spent good amount of time and efforts to optimize it on ARM. We'll see what some of these optimizations, but as I say, optimization is a never-ending process, so the effort will still continue. In fact, MariaDB was first to add support for ARM. And as I say, MariaDB has a full support or GA, which means all your bugs, whether it's functional bugs, correctness bug or performance bug, will get addressed with the same priority like x86. So that makes MariaDB an ideal choice as a database or open source database to be run on ARM. Now, when you add any additional architecture, you need to face some basic challenges, and ARM is no exceptions. So let's understand what challenges are involved when you port any HPC application to ARM. So ARM is a weak memory order. We all know it's a weak memory order. So to get optimal performance, proper memory ordering has to be used. x86 is a strong memory ordering. So if you are just reporting the code will of course work, but will not get optimal performance. Thankfully, C++11 added a support in its standard for memory ordering, and MariaDB being C++11 compliant was able to harvest this memory ordering support and make optimal use of memory order to get maximum performance on ARM2. Tuning code for ARM. Now ARM is a different architecture altogether. So low level loops or basically code like spin loop, right, needs to be readjusted. I would say readjusted and retuned for ARM processors, because the instructions for pause are different. How much time you want to spin would be different based on the frequencies and all. So accordingly, you have to make sure that code is retuned for ARM processors. So ARM is all about more cores, maybe less powerful, and more. That means more NUMA nodes. So any software that needs to have given with more cores should able to use them efficiently. What I call it to be a NUMA compliant or basically a NUMA optimized software. MariaDB was already NUMA compliant or optimized, since x86 also has multiple NUMA nodes. But additional cores, how to make use of additional core, MariaDB actually have tuned or have solved a lot of scalability issues while working on ARM. And I could say that MariaDB is now completely pretty well optimized for more cores that ARM processor throws at it to make maximum or optimal use of these processors. Beyond that, ARM do provide some acceleration instructions in form of Neon SIMD LSE. So atomic instructions, special atomic instructions, or optimizations of it. So all these, even with vectorizations and all these things are also provided by x86. But since the code or these are low-level hardware instructions, you may have to write a parallel code along x86 for ARM purpose too. So making sure that you tune all such code snippets and enable them for ARM from optimization perspective is also important. ARM has a different cache line requirement, so making sure the cache lines is adjusted. Alignments, memory alignment hints could be needed. There could be pipeline differences. A code which could be hotspot, which is not hotspot on x86 could be turned out to be on hotspot on ARM. So making sure you discover such code, retune them is needed. And switching to use hardware optimized support. So there are few functions which hardware can also do. For example, very good example of this is checksum. So when x86 also provided such functionality where it could compute some of the things directly at hardware level and they're faster. And the same support is also offered by ARM. So making sure that you discover such code and get it ported and use the relevant functions from ARM hardware architecture is important for making software performance optimal. So these are few challenges that any HPC software will have to face, and of course MariaDB has already faced. So if you look at the complete solution, all the issues, then you could this is a partial picture that we are trying to provide. MariaDB have addressed almost on all front some optimization has been done, whether it's memory ordering. So memory ordering has been taken care of. We just talked about one of such challenge. NUMA scalability, even on NUMA scalability like spin lock optimization, timer counter optimization, cache line sharing, all such more optimizations has been taken care of. Whether it's use of neon, even that has been taken care of. Moving to atomics so that it is able to scale correctly. Use of checksum, we just talked about the checksum example, making sure the hardware checksums are used. So when MariaDB made optimized MariaDB server for ARM, they made sure that the optimization is not only done in one direction, but all aspect of optimization for HPC softwares are taken care of. And the result of this is the complete upliftment on all scenarios, or I would say all use cases. You could see that MariaDB server on ARM performs better. So all these good optimizations, let's understand how they are going to help. Okay, so only one way to find out is by benchmarking. So we will try to look at some of the benchmarking numbers with this. Before we get into the real benchmarking, let me introduce you the cost performance model. I'm sure you might have heard something similar to this in past, but let's talk about it. What I meant by a cost performance model. If you boot a ARM instance and if you boot an x86 instance, roughly with the same size of computing power and memory, you would see that almost on all cloud provider, ARM instance provide a decent saving anywhere ranging from 20 to 50%. So that is expected because that's the USP of ARM resources. So of course, the idea now would be that can we leverage this cost saving and still get improved performance. So if I can run the same software on x86 with the same configurations and on ARM, and if I could still get on par performance, I could say that I have achieved a 40% saving. Okay, so this is the existing model, but there are challenges, right? The challenges are CPU frequencies when you compare two instances of ARM. Like here, if you compare on Huawei Cloud, the Kunpeng ARM instance is 2.6 gigahertz, while the respective instance of x86 is have a base frequency of 3.0 gigahertz with a turbo frequency of 3.4 gigahertz. So these frequency differences make the comparison challenging or basically not on par. Beyond that, Intel has turbo mode, which means on lower scalability, Intel is always going to score because it is going to use its turbo mode. Now, CPU generation differences are also there. Now, Intel itself being in race for quite some time now, it has its Broadwell, it has Skylake, it has Cascade Lake, and more such things. So there are CPU generations differences. Now, x86 cores have physical core. There's a concept of physical core versus HT core, what we call as hyper-threaded core, and what cloud provider provide you is vCPU, right? So there are these differences. There could be NUMA arrangement differences. NUMA make a difference, and with increasing cores, more NUMA nodes will be there. There could be memory differences. Scheduler, what I've heard is with kernel, Linux kernel 5.x, there is improved support for multi-NUMA architecture. So that's another thing to consider. So with all these things in place, it's important that we can't directly compare, or it would not be an apple-to-apple comparison just for purpose of cost saving. So we developed a different model, or we just proposed a different way of looking at it. What if we could say we could keep the cost constant, and let's analyze if we can get more throughput on ARM, thereby turning into more TPS per USD. So if I put it more formally, if I have X USD to be spent, what I'm going to do is I could get M ARM resources and N x86 resources, of course more ARM resources. Can we get increased performance from these M ARM resource? So for cost constant with ARM resource, I'm getting more performance, thereby it is increasing my TPS per USD. I put it more into form of definition. Given the on-par cost of both the resources, can we exploit ARM variant to its fullest benefit and get better performance when compared to x86? I think that's fair enough to consider. So let's understand whether we can apply this model and then analyze how ARM performs with respect to x86 using MariaDB as an example. So this is just a quick example of if you try to boot a VM on Huawei Cloud, almost of the same cost, x86 and ARM, you would discover that, and the memory is also same. For the keeping all other configurations same, it typically looks to be that the computing power is almost double. Okay, so there are 2x more core. I shouldn't say computing power because there is a frequency differences, but let's assume that you can get almost double the cores or 2x more core for ARM. Now these extra computing power is surely going to help you scale better on ARM versus x86. The difference looks to be 2x on VM. With bare metal, this difference further increases. So we'll see, with how this particular extra computing power is going to help us. So this is a typical setup that we will be using. So this is all testing is using Sysbench. So most of us would be familiar with this. We would be using data which is of 69 GB in size. We will be testing it on two things. One is a CPU bound workload where we will provide enough buffer pool, and an IO bound workload where we will provide a lesser buffer pool. Redo log is good enough too. We would be using two different versions of MariaDB, 10.4.13 and 10.5.5. So 10.5.5 has some performance regression on the flushing front. So which is actively being fixed by MariaDB team. So just for a fair comparison, we will use one older version where this particular regression is not present. So we'll get a good idea of how ARM is performing. And we'll also see the result in 10.5.5 where also ARM is performing. So test scenarios, we will look into Sysbench, point select, read only, read write, update index, update non-index. Machine configuration, we have used a bare metal and we have applied the CPM model. So for the same cost, we could get 28 HT core of x86 and 64 cores of ARM. Okay, so that's the normalization done on using CPM. And storage, we have kept the same storage for both of it. The IOPS are almost or comparable on both of the storage. So that's the short, that basically by keeping all the other configurations same, only by changing the computing power, that would make it easy to evaluate whether ARM really perform. Okay, so with that, let's see the results. This is MariaDB 10.4.13 workload, CPU bound workload. The blue line represents ARM and red line represents x86. As you could see, almost on all use cases, ARM continue to perform better than x86. Importantly, with increasing scalability, the difference of performance further continue to grow, and ARM continue to surpass after some point. In fact, on for read-write workload, the difference continue to be better with significant margin with the ARM. And even for read-only workload, bearing some small crisscross, we could see that ARM has been able to perform quite better on all the use cases. Now that's CPU bound. Let's talk about what about IO bound. So IO bound also present the same picture. As you could see, for all IO bound workloads, ARM, which is again a blue line here, continue to scale better and surpass or beat x86 on almost all front, including read-only and read-write. So this is MariaDB 10.5.5. As I said, MariaDB 10.5.5 has some performance regressions, so which are being actively fixed. But I thought it is worth adding the results. And as you could see, even with this, ARM continue to beat x86 with increased scalability. So again, one thing which is prevalent is that on all these workloads, ARM scales better. Thanks to the extra computing power that is present for the same cost, that is making it scale so better versus x86. TPCC, so this is also gaining quite a lot of traction, or people do use TPCC also for a lot of validation. So I thought I will also add this results just to check how it does. And as expected, ARM continue to perform better than x86 quite significantly with increased scalability. Even for lower scalability, difference is marginal. I would not say it's a huge difference. So difference is marginal. And once a scalability point cross, then ARM just picks up and perform almost doubles the throughput compared to x86. Okay, so all these numbers, but then eventually probably we want to put them into some numbers using which we can justify the cost saving. So this is just an example. I have assumed the cost of the machine somewhere about 800 USD, and then I tried calculating TPS per USD. So I'm using one such data point, 1024 thread update index use case, and this is with 10.4.13. We use both CPU and IO bound. If you look at the numbers, then the TPS, that is transactions per second, given for ARM is always higher than the transactions per second for x86. Now that effectively means the TPS per USD is of course better for ARM, and that directly translate into a saving, because for the same cost I could get more work done from ARM versus x86. Now, typically, if you want to put it in another way, I would say there's a point when you would hit a threshold and you will have to take a decision that, well, I have to increase my computing power. So you have two options, right? So either you can go and buy a bigger x86 machine at extra cost, okay, and get your performance scaled, or you could simply keep the cost same and switch to use of ARM and still get a better performance or increased performance. So that way it directly translates into a cost saving. Even in form of clusters, if you have a master slave configuration, then of course you would find out there too, if you are booting a 5 node cluster of x86, maybe you'll have to boot a 4 or 3 node clusters of ARM, and which effectively will generate a significant saving. So from all these experiments, it is very much clear that MariaDB on ARM is a cost-effective solution as compared to the other flavors. So with that, let's talk about the state of the ecosystem, because when user adopt a software, he needs to also make sure that the ecosystem is up and running. So that's a quick intro about ecosystem. As you could see, the green blocks are already present on ARM. So server, of course, is there. Backup is inherent tool of server, and so is the cluster. solution, whether it's Galera cluster multi-master solution or Binlog. They are part of the MariaDB default server. Things which are in red are not yet part of the ecosystem or have official packages on ARM. But they do work. For example, a few days back, someone from Percona actually compiled PMM or Percona Monitoring and Management Tool on ARM and was able to compile and get it running successfully. Now, with community support, we can actually make sure that all other remaining components also are made available on ARM in form of official packages. So the question is why we aim for completion, because if you are running part on, of course, you can still run part of these components on x86, because anyway, they will talk MySQL protocol and they can communicate with the server on ARM using that protocol. But having everything on x86, on ARM would help you get significant cost saving. So I think that is the reason why we should aim for completion. There are other supporting tools of the ecosystem. Like for example, if you are running on Kubernetes, it is available on ARM. If you use VTest for sharding, then probably it should get available on ARM. So with community support, we if we start asking, then respective organizations which own that tools or have been developing that tools could make them officially available on ARM. Same with migration tools. So that's why I say I think the community support is very important for upliftment of this ARM ecosystem. Whether, like we just talked about PMM, there's a Jira ticket open for max scale packages. So go ahead and like it. MariaDB will surely consider it if there are more community interest on making max scale packages available on ARM, connectors on ARM. As I already talked about distro, for distro we are already talking with MariaDB organization, and they are going to add more distros beyond CentOS and Ubuntu. So I think this is going to, community support will always help. And as I say, development still continues, right? So MariaDB, ARM is on their mainline plan. So they do consider ARM compatibility while they develop any new feature. The DB ARM community is growing. They have contributed a lot more performance patches, bugs, making sure that ARM64 wider hardware compatibility is possible, because ARM is an open architecture. Lot of companies develop their own ARM processors using the main design. So making sure that the software runs on all these ARM processors. And if you have any issues and if you wish to join or contribute back to MariaDB on ARM, there is a dedicated channel on community chat of MariaDB now, which is called MariaDB on ARM. So I'm going to end this talk leaving you with a message which says, let's make MariaDB great again on ARM this time. We all know MariaDB is great on x86. We are just saying that let's make it great again on ARM this time. Hope you all the community people would be able to support this. And next time when we talk about it, MariaDB on ARM would be the best open source DB available. Thanks for attending. If you have any questions, you can of course put it over Twitter. I have also an active blog. There's also GitHub. You can find my contact details also. So if you have any questions, of course you can ask on the channel also and post it to me too. Thank you for your time and thanks for attending the talk. Thank you.